Hello, welcome to another problem session. Today we're gonna address a problem in what you will call relative velocity. So it's relative velocity. Okay, what does the relative velocity in the relative velocity concept mean? It means you have two coordinate systems or two frames. I think it's easier to think in terms of coordinates, but you have two frames of reference, and the velocity of the same object with respect to two frames will be different. And so if you know the relations between them, then you can work out numerical predictions and things like that. So here, what are the two references we're talking about? So in this figure, you can say there's a shore-based frame, and then there is a frame that kind of moves with the river. A river-based frame, a river frame. So there's shore frame and there's river frame. So let's think of these numbers given here in which frame is what. So it says this. Let's look at this one. The speed of the river be 2 meters per second. Well, in the river frame, a river is not going anywhere. So this information is actually with respect to the shore frame. So this is, you can write this as velocity or with respect to shore frame. It's not given here in the problem, but you have to interpret it properly. And this speed, the speed of the boat in the calm water, is just saying that whichever direction the boat is going, it will be with respect to whatever medium the boat is in. So if the boat is tied to the shore, if the boat was if the river was calm, then the boat will go at that speed in whatever direction you point. So if the river is moving and you have to point the boat to some other direction, then it's going to move in the direction with that speed. So is the speed of the boat itself, the speed of the boat in calm river. So what does it say about this here? So if I have to point the boat in that direction, then in that direction is going to cover 5 meters per second. So this is the 5 meters per second. But the boat, I want the boat to go in that direction, right? I want the boat to go in that direction. Now this will be unknown. And I want this speed to be with respect to shore. So we want to know what the V net will be with respect to shore. That is the hard part to realize. Once you realize, you can actually draw a vector diagram and very easily solve this problem. So here will be the vector diagram. Is V net, and river is going this way, V river, and this is of course with respect to shore. V net is with respect to shore, and then this is the direction you have to point, and so this will be V of the boat with respect to river because it's going on the river. So this is the river frame. So these little superscripts I have placed, they are referred to the frame. Okay, so now this is a vector diagram, and in here it's very easy to say this vector plus this vector gets you the same place as this vector. So V net, so for sure, is equal to V boat with respect to river plus V river with respect to shore. And we can just take it x-axis and y-axis directions like that. And if you look at the x direction, y direction, so this V net has only y. So this is 0 along the x direction. V boat along is along this x will be V boat times I want opposite, so sine theta. So V boat, let's call it V boat sine theta, and the river is just V river. So this one equation, and the y direction I got another equation, right? Y direction will be, this will be its V net, whatever the magnitude is, and V boat, now very careful, this thing is pointing that direction, pointing that direction, and you have a theta here. So I think this was the x, so it should have been negative here, and the y will be positive, so y is positive VB cosine theta. So I wasn't very careful, this negative sign is important. And V river doesn't have any y, so that's going to be 0. So this is known, these are known, and so this is unknown. So in here sine theta can be used to solve for theta, right? So I use this. Is now, that's the strategy to find something I can isolate it. So sine theta is equals to sending sine this thing that side divided by V bar, so VR over VB, and VR is going to be 2, and this is going to be 5. So sine theta is, then theta is arc sine of 2 over 5. Okay, and you can look up in calculator. So and from here I need a cosine theta, because we already know. So from here we can do cosine theta is square root of 1 minus 4 over 25, and that's going to be 3 over 5. So cosine theta is that, and so V net will just turn out to be VB is 5 and 3 over 5, so this is 3 meter per second. So that's this this is the angle, this is the part A, but once you find the speed we can find the time, because we know that how wide the river is. So the time it will take is 150 meter over 3 meter per second. So say 3 meter per second, and that gives you 50 meter, and this is 50 seconds. Okay, so this is B. Okay, so to recap, you whenever you encounter relative velocity, think of 2 frames which are in motion with respect to each other. And once you have done that, think of what velocities with respect to what this. So this is V river, which velocities you know with respect to which frame. And then there will be this information then gets translated into a vector diagram, and then vector diagram gets put into a component picture, and then this vector diagram leads to a vector equation, and then that using the component, and you can do component wise, and then you figure out which one to solve first, and then from there you proceed. So when you systematize your thinking in terms of two frames, it's really helpful. Hope it helps you solving other problems when you encounter relative velocity problems. Okay, talk to you later. Bye.